Well, hello and welcome YouTube. Mr. Robinson back here with yet another brand new exciting video, all math-based of course, and as always, it is an honor and a privilege to be serving you here today, as it is every day inside my virtual classroom. Welcome to 2021. I think this is my first public video to do with everybody on YouTube for math. I've done some private videos for my students for different reasons, but this one's a solution guide video for some setting up and solving systems of linear equations that use standard form. We've been doing some things with slope-intercept form, and I don't think I made a video for them, so to speak, because I didn't do things out of our book. We did them in class, yada yada. I will give you some old videos of mine that I think cover both of these topics if you think this is a little too much or not enough. This will be 16 problems that I set up with defining variables, and the last 8 of them I also solve with you. So I'm just going to rummage through them right now, and I'll show you some caveats starting right now. Let's just look at them. With the first set of problems, the very first 8 of them, they do actually say write them, and I put define all variables, that's me, and then do not solve. Now, when it says do not solve, it also throws into the ring that it's not expecting you to because it's not going to ask you a question. I personally think the question that they ask, whether or not we solve, is really important because it helps us understand what variables we're going to use and what they're going to represent in the context of the situation. So take number 1, for example. There is no question at the end for blah, 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 blah. We'll go into this question, and I'll give you the equivalent of what the question should be. But, you know, how are my students supposed to do this? That kind of thing. You can see number 2 and 3, etc. There's no question here. They give you information. They say write an equation. I say define variables. We'll get into why in a second. And they end at number 8. And then once you hit number 9, there is a and then solve the resulting system, because then they ask you a question there. How much time did she spend at each gym? And that how much time is really nice because it helps you understand what it is you're trying to figure out. You know, what the variable is that you are actually defining. So all of these will have questions, which will make these easier in that way. But of course, in these problems, we're going to have to solve them as well. So I'm just letting you know about that, guys. And of course, like I said, I am going to be asking us to define variables, or I mean, if you are in a virtual class with me, I'm asking that. I'm asking my students to do that for particular reasons. Number 1, I think it's easier to set up your equation and knowing what your equation actually means. And number 2, knowing what your answer actually means. I don't want them to set it up as far as busy work goes if they understand how to do both things incredibly well and they can interpret what all the terms mean. Maybe defining variables isn't the key thing, but I want to be consistent with all my students in that regard, so I just will. Okay, so here we go. Write a system of equations that corresponds to the situation. Define all variables. That's mine. Do not solve. So to save time, I won't solve 1 through 8, but I will help you with the unknowns, what it is we would try and find out if they asked us to solve. Okay, number 1. Lisa spends part of her year as a member of a gym. She then finds a better deal at another gym, so she cancels her membership with the first gym and spends the rest of the year with the second gym. The membership to the first gym costs $75 per month, while the membership of the second gym costs $50 per month. She ends up spending a total of $775 over the course of the year. So if we just look at some parts here, she is spending time at a gym throughout the year, whether it's one gym or the other gym. She spends, where is it? First part of her year as a member of a gym, and then the rest of the year with the second gym. So with the per month portion, what we can probably at least assume in one thing is that she does spend a certain amount of months, whole integer months, at a gym. So it's not like she probably spent like 2 weeks at a gym. Let's assume she at least spent 1 month or 0 at one of the gyms. So she spent the whole month there. And sorry I keep babbling about months and months, but that's what we're gonna have to talk about here. One gym costs $75 per month. So however many months she spent there, she spent $75 for every month she went there, and you add those up. And then $50 for the other one. And then those somehow add up to $775. But the other part, of course, is she spent the entire year at both gyms, but we don't know how much time she spent at either gym. And that could be the question here. How much time? Actually, that sounds like the number 9 question. I don't know if that had to do with gyms. Yeah, I think it did. How much time did Lisa spend at either gym? That's really the question that would be asked here. And not that I'm doing the questions, not that I'm having my students write the questions down, but when you do end up solving systems, this is the kind of stuff that you want to look at. How much time did Lisa spend at each gym? At each gym, not either gym. How much time did Lisa spend at each gym? How long was she a member at each gym? And that's kind of the big question being asked, and that's important to know because that helps you define your variables. What we don't know are our variables. Some people say something like, oh, X is first gym cost. No, X isn't first gym cost. The first gym cost is 75. We know how much that is. So we're going to let X, and I'm going to use X and Y because, I don't know, just because. Number of months at first gym. Number of months at first gym. If this takes too long for me to write, I'm eventually probably going to start typing them just for the sake of video time. And then let Y equal number of months at second gym. That way when we solve for X and Y, not that we are here, but in a different problem, we know exactly what that number represents. And this also helps us with our equations. Okay, equation-wise, we're going to create two equations for the system as we have two variables to solve for. And they come from different bits of information. One bit of information has to do with the concept of spending a whole year at both gyms. The number of months she spent at one gym plus the number of months she spent at the other gym equals a year's worth of months. That's 12 months total. This is a time equation. This is a time equation based on how much time she spends at both gyms combined. Now there's another equation that's going to be money-based. There's going to be a money-based equation here that has to do with the amount of money she spent at both gyms here. If she spent X months at the first gym, and she spent $75 per month there, then she spent a total of $75 per month times the number of months that she went there. 75x represents the number of dollars she spent at the first gym in total. In total, 75 per month, X is the number of months. If it was 10 months, 75 times 10 is 750. Now, I don't think that's the answer because 775 is the total, and the other gym costs $50 at a time. So the other one is $50 per month times the number of months at the second gym there, and total this becomes 775. So this becomes your system of equations, guys, and again, the explanation that I state is times the number of months. When I say that out loud, that really seems to represent that. You can't just say X equals first gym, Y equals second gym. That doesn't make a lot of sense about when I get a number for X like 10, what does that mean? 10 first gyms, 10 pounds lifted at there. You need to be very specific about what you're referring to. What are the units of measurement and how are we quantifying it? Sometimes they're dollars, sometimes it's time, things like that. All right, so here's the system. We could solve it using elimination. We won't. I'm going to go ahead and move on, but there's the setup there. I feel like typing these parts if that's going to be all I have to do there for the first several here. All right, number 2. Yeah, let's start typing these. Jack is selling tickets to an event. Attendees can either buy a general admission ticket or a VIP ticket. The general admission tickets are $60 and the VIP tickets are $90. He doesn't know. Oh, they kind of tell us this time. He doesn't know how many of each type he sold, but he knows he sold a total of 29 tickets and made $2,100. So the question is, how many of each type did he sell? And that's the idea here. We don't know how many general admission tickets he sold. We don't know how many VIP tickets he sold. So I'm going to do another X and Y here. They spelled admission wrong here. Admission ticket. Admission. Is that an admission ticket? All right, let's let X equal the number of general admission tickets sold and let Y equal, I don't know how to get the spacing perfect on that. The one problem with typing is formatting. And let Y equal the number of VIP tickets sold. So, one more time, we know the cost of a general admission ticket. We know the cost of a VIP ticket. We don't know how many are sold, and that's where the variable jumps in. So that's my X and Y there, and then let's go ahead and write two equations, or type them in my case here. And in typing them, we're going to get, let's see, the total 29 tickets sold. So again, there's going to be one equation that has to do with a quantity, if you will. Tickets sold. So there's a tickets equation. I'll put it that way. Tickets equation that's X plus Y equals 29. I really feel like I should actually handwrite this part. I'm going to handwrite this part next time. And then there's a dollar amount collected. There's money collected. He made, I'll just put money. He made $2,100. So this part is going to be same thing as kind of last time here. We're going to have like a, let's see, 60x. 60x represents the amount of money made from selling X general admission tickets. And then 90y ends up being the amount of money made by selling Y amounts of VIP tickets. And total, that's 2,100. Yeah, I'm going to handwrite this part because it's hard to look at the keyboard with this at the same time. All right, so that's my system of equations on that one there. This isn't necessary to write right here, but identifying what kinds of equations you're writing is pretty important. Sometimes people maybe know how to write the equations. They just don't know what kinds of equations to write. I mean, it's based off the information clearly, but that's also why defining variables is really good, because then you know what units you're covering in here, and then you want to know how you're doing this. Remember, guys, this top equation, and then I'll move on. This top equation is tickets. This is number of tickets plus number of tickets equals number of tickets here. And this is number of dollars plus number of dollars equals number of dollars. Sometimes I'll ask a student that says, what does 60x mean? People will say 60 tickets or 60 general admission tickets. That's not what it means. We don't know how many general admission tickets sold. That's the point. $60 per general admission ticket. Sometimes people just say that, and I say, no, there's more to it. It's multiplying by something. And what's that something? It's how many they sold. So once again, if he sells 10 general admission tickets, that's $600. This is a dollar amount. This is how much money made from selling X amounts of general admission tickets. All right, number 3. There are 200 adults and 300 children at a zoo. The zoo makes a total of $7,000 from the entrance fees, and the cost for an adult and a child to attend is $30. I assume these are separate. Adult is $30, child is $30. It's $30 regardless. I don't think that they mean an adult plus a child is $30 total. I think they mean separately there. So, okay, it costs the same amount whether you're an adult or a child. However, we still don't know not how many adult and children attended. We don't know. Well, let's see. What don't we know? 200 adults attended, 300 children attended. So we know how many attended. $200 adults, 300 children. I don't. Oh, we don't know how much. Oh, wait, no, we do. What do they want? Oh, maybe it is. Maybe. Okay, I messed this up. Maybe they are saying that this collectively is $30. Otherwise, I'd say, like, they don't want anything from us. We've solved it. We know. But, yeah, they're saying we do not know how much an adult ticket costs or how much a child ticket costs. This is a collective sum for both of them, okay? So this question is, how much... This is me not previewing this stuff before. How much does an adult ticket cost? How much does a child ticket cost? And remember, we're not solving this together. We'll do the later ones after that. How much does an adult ticket cost? How much does a child ticket cost? So let's do let's use different letters this time. Let's actually use A and C. You know, just kind of keeping in mind you can do stuff like that as long as you define them. So I'm going to let A equal not the number of adult tickets. We know that information. This time it's going to be the cost of an adult ticket in dollars. And then let's C once again equal, or same scenario here, cost of a child ticket. The two times that I don't are there two? I'll think about it. The times that I don't recommend you use letters outside of X and Y when you're defining variables are either if your letter resembles a number too much. I tend to avoid using S's because they look like 5s, O's because they look like 0s. I personally am fine using L like a 1. Or here's why. Sorry that I'm kind of jumping out of the problem for a second. I don't mind using L because I write it like that, and I could write a 1 like this if I have to. I don't mind using a T because I curve it instead of the plus. I don't mind using a Z because I put the cross instead of a 2. but some people don't have those things kind of look different from their other bits. And for me, my S's can tend to look like 5s, so that could be an S, that could be a 5. And if I differentiate them, that's fine, but my 5s start to look like this in general. So, just be careful. And then zeros and O's is kind of hard. Maybe you can put that for the 0, but now it's like theta, Greek symbol. So anyway, it's kind of weird, all depending on the letters there. So that's one time I'd try and avoid it if the thing you're setting up kind of starts with that one letter and it looks like another number or symbol. The other time I'd probably avoid doing it is if I'm graphing them, because if I want to distinctly show what the X and Y axis are, maybe I don't want to mess that up. Now I'm talking about an X and Y intercept or a T intercept and an R intercept, and it kind of starts to sound a little weird. So those are the only 2 times I probably wouldn't use things outside of X and Y, but here it's fine. A and C are fine there. All right, guys, let's set up this equation. Sorry about that. So, or the system of equations. Ooh, I said I wouldn't type it this time, and I will not. So here we go. System of equations this time. Let's start with the top easier equation here, which will be combining my adult and child ticket prices. If I combine them, adult plus child ticket, that'll cost $30 in whole. So again, this is a cost per ticket. This is a cost per ticket price. And then the other one is a total amount collected here, cost of all tickets. And this is going to be kind of like those other ones where I got to multiply something. So there are 200 adults who attend, and if you multiply that by the cost per ticket for adult, this is how much money you make for adults here. So this one is a little different, because this is the one that's going to be actually harder for people, not to write out, but for people to interpret. If I say, what does 200A mean? A lot of people will say 200 adults. Because now there are 200 adults, but that's not what this means. This still is a dollar amount. This is 200 adults times however many dollars it costs per adult. So again, defining variables. I'm trying to still be convincing on the defining variables bit. I promise I'll go faster after this here now. Plus 300 children times the cost per child equals $7,000. I have other things to do as well, so the fact that I've already spent 17 minutes doing 3 problems is a little iffy. All right, let's speed up, shall we? Number 4, a local fish market is selling fish and lobsters by the pound. The fish costs $4.50 a pound, while the lobster costs $9.50 a pound. We know how much each of them cost. The fish market sells 25.5 pounds and makes $189.75. They sell them by the pound. I understand that you might think the question is how many fish and lobsters did they sell, but we don't have information to provide us that answer, but we can figure out how many pounds of fish and how many pounds of lobster they sell. That'll be the question here. How many pounds of fish and lobster are sold? Okay, how many pounds? So when we define variables, it's not let F equal fish and L equal lobster. By the way, L with lobster might be one where I don't define the variable that way. Let's use X and Y here again. So let's let X equal number of pounds of fish. Pounds of fish sold. You can say pounds of fish sold. Pounds of fish sold. And let Y equal pounds of lobster sold. Okay. Not number of, pounds of. All right. The typing just throws off. I have to format them and stuff too. All right, here we go. So equation-wise, I'm glad we're not solving this one, though I imagine we're going to be doing one with decimals down the line. I imagine I'll have to use a calculator down the line as well, which I'm not prepped for. I got to load that up. All right, so 25.5 pounds in total. X plus Y equals 25.5. Yeah, there's a decimal amount there, but I add the number of pounds of fish sold and the pounds of lobster sold is 25.5. So, $4.50 a pound. And you know what might help here, actually? As long as you remember how to interpret it, I don't really need this trailing zero. It's not going to help me very much. 4.5x plus 9.5y equals 189.75. I mean, eventually maybe it comes back anyway, but I'm kind of letting you know that that's not required here. If you had to solve this as a system, maybe not having that trailing zero might be helpful for you. I don't know. I'm just saying that it could be. Knowing that you can do that is nice. All right. Jennifer has 12 nickels and dimes. The value of her coins is $1. Now, it seems like they don't give a lot of information as it's only one line and 2 sentences here. And you might be wondering, is the question how many? So 12 nickels and dimes means not 12 nickels and 12 dimes. It means a total of the number of coins is with nickels plus dimes is 12. They don't tell you what the value is of each nickel and dime, but that's something that's supposed to be known. They expect you to know that. So we know that a dime is 10 cents and a nickel is 5 cents. All right. Now, there's something else I'm going to write to that after we define our variables here. So we don't know how many of each there are. How many nickels are there? How many of each coin type does Jennifer have? Okay. So we're going to let's use N and D, I guess, this time. Let's let N equal number of nickels she has, and D equal number of dimes. Oops, I spelled nickels wrong. And D equal number of dimes. All right. Now keep in mind, one more time, value-wise, a nickel is 5 cents. A nickel is 5 cents. See how my 5 looks like an S? And it's also here, I'm going to write this just in case we end up using this, because I'll show you also as well. Dollars-wise, it's $0.05. And then a dime is 10 cents, but that is also $0.10. Now, that's not my equation stuff. That's to help you understand information that they didn't provide that you kind of have to know. Now, the information they provide for us to write equations would be N plus D equals 12. Number of nickels plus number of dimes is 12 coins total. And then here's the next part. The next part's a money-based thing, but would you rather do a cents-based equation or dollars-based equation? It's up to you, but keep this in mind. You can't merge cents with dollars in the same equation here. So you can either do a cents equation where you say 5 cents per nickel times the number of nickels plus 10 cents per dime times the number of dimes equals, now here's the important part, some people will say $1, but you can't do that. This total unit is cents and this is cents. It doesn't equal 1 cent. It equals $1, which is how many cents? That would be 100 cents. So if you want to write an equation in this format, that's fine, but you have to convert this into 100 cents. That is a must for this. Or you must do it in the dollar realm, which is 0.05N plus 0.10D equals then $1. You can do that. Now, I personally like the cents one more for 2 reasons. Number one, I just like saying 5 cents instead of saying $0.05. And number 2, even if I wrote this one out anyway, I'm not a fan of solving using decimals, and we're not solving this one, but I'm sure there will be another question asked like this. So I would convert it to this anyway. Not just cents, but I would convert to non-decimals. And that would be a decimal shift. We're going to look at that, I'm sure, later. Okay, number 6. The sum of 5 times one number and 2 times a second number is 57. The sum of the 2 numbers is 18. Okay, this isn't really a context-based thing anymore. This is like one number and the other number. We need to know what the 2 numbers are. So let's let x equal, I'm just going to handwrite these from now on. I think the typing was more hurtful than helpful. Let x equal one number. Let's see. How about first number and second number? Let x equal the first number, just so we know which one we're referring to when we write them. We don't accidentally switch them up during mid-equation. And y equals the second number. Now, there's still 2 equations to write with here. Let's see them. The sum of 5 times one number and 2 times a second number is 57. So the sum of 5 times one number and 2 times a second number, first number, second number, is 57. And the sum of the 2 numbers is 18. There we go. There's your setup. I'm going to leave it at that. Let's go and move on. Number 7, Gary goes to the grocery store to buy hot dogs and hamburgers for a cookout. He buys a total of 8 packs. That comes to a total of $28.52. A pack of hot dogs costs $229, $2.29, and a pack of hamburgers costs $5.69. How much of each pack did Gary purchase is the question. Okay, let's go without writing that. Let's see if that makes sense. Hot dogs and hamburgers both start with H, so I'm going to avoid doing that. I know you could use D for hot dogs, stuff like that, but I'll just do X and Y. Let's let X equal not number of hot dogs, number of hot dog packs. Number of hot dog packs. Hot dogs packs, hot dog packs. Hot dog packs that Gary purchases. And let Y equal number of hamburger purchases. I apologize if I end up, well, 2 things. Number 1, I apologize for clearing my throat a lot. Number 2, I apologize if my volume fluctuates in my actual voice. If I start raising my voice like this a lot. I recently lowered my mic volume a little bit. And in turn, I want to yell a little more. The problem is I sometimes just start lowering my voice a little bit like this. And I forget that I lowered my mic volume. So I got to keep projecting. So sorry if I'm quiet for a little while. And then I start speaking up more like that. I intend to actually project more, which is why I wanted to lower my volume. All right. Not purchases, packs. Not purchases, packs. Number of hamburger packs that Gary purchases. All right, so here we go. That is X plus Y equals 8. Number of hot dog packs purchased plus number of hamburger packs purchased equals 8 packs purchased total. And then $2.29 per pack times the number of hot dog packs plus $5.69 per pack times the number of hamburger packs equals $28.52. There's the setup. All right, number 8 here. The sum of 2 numbers is 18. Or I don't know where I'm going with this. I'm getting kind of hungry. You know what I'm going to do, guys? I'm going to pause this video. You won't know it. Or I guess you will, because it'll pause and unpause. But I'm going to pause the video. I'm going to eat, and then I'm going to unpause and finish recording this video after I do this problem. I hope that's okay, because the hot dog hamburger thing one just reminded me that I haven't had food since this morning, and right now it's 6 p.m. So there we go. All right, the sum of 2 numbers is 28, and the sum of 6 times the first number, 3 times the second number is 105. Just like last time here, guys, X is the first number, and Y is the second number here. Sorry, I'm getting really hungry. I feel like actually making something here. So this is like last time, guys. X plus Y equals 28. I don't like these problems as much. I mean, they're good for you to learn, to set up with, but I like the ones that have context to them, because they're telling you straight up out loud what to write, as opposed to just figuring it out on your own. 6 times the first plus 3 times the second is 105. Can't wait to solve problems like this, but setting them up for me is like, I don't really know much to say on that, guys. All right, I'm going to leave it at that for a second. I will come back. I'm just going to pause this recording, and I'll come back for you guys later. Okay, I'm back and more nourished than ever, I sure hope. And let's finish this. I have numbers 9 through 16 to keep going on this problem set. I want to spend less time kind of explaining how I'm doing some of the stuff and focus more on the solving and interpreting the solution. Make sure you know that. So if you want to look back at numbers 1 through 8 as far as how I define my variables, you're going to know how to define the variables pretty easily here because the questions will be asked, but how I do it specifically and then how the equations come to be. I think this will make, I'll say them out loud, but I'm not going to spend time pausing on it during the problems. Okay. So find a system of equations that corresponds to the situation and then solve the resulting system. Of course, I will be defining variables in this stuff as well. Okay, Jan spends part of her year. Okay, so this looks like number 1 a lot as far as the gym stuff. Part of her year in one gym, finds another gym. Gyms cost this much, this much. Only this time it says if she ends up spending a total of $645 over the course of the year, how much time did she spend at each gym? So now we're actually going to solve this one after the fact. So we're going to use X and Y again for like first gym and second gym, but specifically, I'm going to let X equal the time spent, the number of months at first gym, and then second gym as well. That is an at symbol at first gym, and then number of months at second gym, if that's okay for you guys. Okay, so the first equation, and you don't have to put this as the first equation, but the easiest equation to write like last time here, focus on number 1 if you recall. X plus y equals 12 is an equation that says I spend X months at one gym, Y months at another gym, and that equals 12 months total because that is a year. That's what they say, spends the rest of the year at the gym. All that. The other equation is $80 per month at the first gym times X months is how much money I spend at the first gym. $45 per month at the second gym times Y months spent at the second gym equals $645 spent total. We have to now solve for X and Y. We have to figure out how many months she spent at either gym here. Now, in order to do this, I'm going to start recommending this right off the bat and see if you can work on it afterward. I'm going to solve these using elimination. Now, you can use the substitution method if you get Y by itself or X by itself on the top and then substitute. But I've done a lot of substitution with my classes the other times. I'm going to use elimination. Now, one option to this is just, hey, let's multiply the top by negative 45, so then we can go ahead and eliminate y's right there, and then whatever 45 times 12 is. What I'm going to do, however, slightly different, and it's this. I'm going to start and make my second equation smaller, because if I can work with smaller numbers, I would prefer to. I know, and I'm not sure if this is the largest number, I think so, I know that I can divide all these numbers by 5 in this equation here. If I divide by 5 and by 5, then I'm going to be getting 16x plus 9y equals, and 600, shoot, 120, 129, 129. And I think that's as small as you can get. Now I can take the top equation and multiply by negative 9 instead of negative 45. C times negative 9, and that'll now eliminate my y's here. So negative 9x minus 9y equals negative 108. And I'm just left with smaller numbers. I don't need to use a calculator this time for myself, and that helps me personally. Now, something you have to do, you can solve whichever way you want. My goal as a teacher, of course, is to give you all outlets possible so you can see what kind of works best in your case. So 7x equals, I don't even know that, 21. And x equals 3. So x equals 3, if I substitute it back in that top original equation, 3 plus y equals 12, so y equals 9. My final answer, I can't just box these, and even during a regular systems of equations problem, you wouldn't be done because you'd want to write it as an ordered pair, but this time we're answering a question. And the question being asked, of course, was how much time did she spend at each gym? And we have to answer that as a sentence. We have to actually state, Jan spent, this is the part I might end up typing later, 3 months at the first gym. I'm going to do the @ sign. And 9 months at the second gym. There we go. And the nice part about these word problems often is that, I mean, it depends on the problem. There might be some problems with money involved and you'd find out how many dollars per something. But generally, we're going to find answers that are integers. And I mean, I guess that's true for the other ones, but you would know if you got 2 point something or whatever that your answer wouldn't really make sense for this particular problem. So you'd know some math got wrong. You'd have to still figure out the math there. But the other part is if there are negative answers for something like time, you'd also know something went wrong. So I kind of like that aspect of word problems. All right, number 10, John is selling tickets to an event. Attendees. So these problems are kind of like the last ones, only different numbers, maybe a different name. I forget the guy's last time. And now we got to solve them. So John said, okay, attendees can either buy general admission ticket or VIP ticket. Look, it's down, same misspelling, admission. So this book, copy and paste job, straight up. Sorry, this is from a textbook for those who are seeing this public from anywhere, from New Jersey or wherever you're at. The general admission tickets are $70 and the VIP tickets are $105. If he knows he sold a total 33 tickets and made $2,730, how many of each type did he sell? All right, I'm going to play some copy and paste. If every problem's going to be like this, let me find that number. This one. Last time was Jack. This time it's John. I'm going to do the same thing. Number of general admission tickets and VIP tickets sold. I'm trying to paste. I just hit the copy button. Let's try that again. Copy. The paste doesn't seem to actually be... It didn't seem to copy that. Let's try that one more time. Copy. Paste. There we go. It would have been faster for me to just write that. But I trust that something will work when I hit Control-C. Of course, it did not. All right. 33 tickets sold. X plus Y equals 33. We sold X general admission tickets, Y VIP tickets. Total, that's 33 tickets sold. And then general admission are $70 per times the number sold, plus 105 VIP per times the number sold equals 27.30. Kind of like last time, I really want to divide everything by 5. I don't know if it makes the numbers that much better here, but it does make them smaller. So I don't know, sometimes smaller is better. And in this case, let's go ahead and check it out when I divide everything by 5 here. Now for you, some people might be like, well, I'd have to use a calculator anyway for these parts. And right now I'm sitting here wondering what this is when I calculate. I don't know off the top of my head. I got to think about it. But so let's see. I know this one is 14, so 14x plus, and that's 21y. Oh, those divide by 7 as well. I wonder if these divide all by 35. They might. I'll have to look into that one. We'll see. Maybe they can all divide by 7 afterward. Let's see here. 5. I don't want to waste your time for me spending time to figure this out, but... Dear Lord. 2750. If I divided... I think it's 52... 520? No, that doesn't make sense. Okay, I'm gonna use the calculator. Sorry. Yeah, sometimes I could get it. I just don't want to... I don't want to waste your time. I don't want to be wrong. 2730 divided by 5. So 546. 546. And I'm checking to see if that's divisible by 7. If I can make these numbers even smaller, that would be awesome. Divided by 7. It is. I get 78. So, okay, I'm going to divide these by 7. So one more time I'm going to do this, guys. These will all divide by 7 here. And I'm just giving you that little outlet of, you can do this if you recognize something numbers divide by here. There we go. So that's going to give me now 2x plus 3y equals, and I think that another number was 78. Yeah, 78. All right, my top equation here, x plus y equals 33. Now I can just multiply this part here by -2, and then that'll get rid of my x's there. Now, now you guys might be asking, which variable should I eliminate? It doesn't matter unless you're only answering a question for one. If this just asked how many VIP tickets did he sell, then I would definitely want to eliminate x because I only need to solve for y. If this asks for general admission, then I'd only want to solve for the other. But when it asks solve for either, then it doesn't matter which order you do it. I'm just choosing the smaller number of the two, coefficient-wise. I chose to cancel out x because this was a 2 and this is a 3. So if I multiply by -2 here, I know this will leave me with a positive. If I multiply by -3 and -3, that would give me with a negative. 2x minus 3x is a negative number. So I'm multiplying by the smaller coefficient of the two. That was my choice there. Okay, so this becomes 1y equals 12. 1y equals 12. So 12 VIP tickets were sold, apparently. How many general admission tickets were sold? Choose an equation of your preference. I choose that top one here. I'm going to get x plus 12 equals 33. Substituting 12 for y, and x equals 21. So 12 and 21 are our two values there. So this time I'm going to type it. John sold 21 general admission tickets and 12 VIP tickets. There we go. Go, John. Make some money. All right. There's the final answer on that one there. Let's box it up. All right. Moving forward. Here we go. I got 6 more problems to do. Number 11. There are 150 adults and 225 children at a zoo. If the zoo makes a total of $5,100 from the entrance fees and the cost of an adult and a child to attend is $31, how much does it cost for a parent and a child? Okay, so one more time, I guess they are doing problems like the last ones, but now you're solving them. So the first time you set it up, and I don't know. So anyway, here we go. There are 150 adults and 225 children at a zoo. Let's see. This is like that one. I was kind of screwing up last time when it said the cost of an adult and a child to attend is $31. I thought they meant an adult is $31 and a child is $31. But no, they're saying if I combine the costs of both of those, it's $31, which makes this actually solvable now when you do it. So I'm going to go back. I'm going to copy the thing. This was the cost. We don't know the cost of each ticket type. We don't know the cost of an adult ticket. We don't know the cost of a child ticket. And that's what's happening here. So when we set up this system here and solve, that's the basis behind it. The adult plus child ticket is $31. A plus C equals 31. And the other equation here was 150A plus 225C equals 5100. And the idea behind this one, if you didn't hear the last time or if you don't remember, is this is 150 adults times the cost per adult. So this is how much money adults spent, how much money the zoo makes from adults only. This is how much money the zoo makes from children, like that. All right, like last time here, I want to divide, and I'm really, really hoping, because I know this can divide by, you might say they can divide by 25. Guys, these can divide by 75. I'm hoping this number can divide by 75. I'm going to go to my calculator and figure out if it does. And if it does, my numbers will be as small as I hope and wish. It does. I get 68. That's good. So I'm going to divide everything on bottom here by 75, personally. Divided by 75. Divided by 75. I'm going to get an equation that says 2a plus 3c equals, what was it, 68? 68. Now, once again, I'm doing this for my own, because this is what I would do personally. I personally do it. You can multiply, immediately, guys, you can multiply the top by negative 150 and go from there. There's no harm in doing that necessarily. I'm just doing this out of, like, I want to keep showing you that it's a thing. And I'm going to multiply by negative 2. And I'm going to get negative 2a minus 2c equals negative 62. So it looks like we're going to be getting, guys, we take out the a's, eliminate, we get c equals 6. C equals 6. That is that how many children attended? No, that's the cost per child ticket. How about the adult tickets here? A plus 6 equals 31, so a equals 25. Okay? A equals 25. So the cost of each adult ticket, is $25. And the cost of each child ticket is $6. Okay. So I hope when we were doing the front end of these kinds of problems, you were starting to connect what you'd have to do here later. I personally didn't know that when setting up these problems, we'd be getting just the another version where you then solve. Sorry for not knowing prior to. All right, number 12. A local fish market is selling fish and lobsters by the pound. Same as before. The fish costs $5.25 a pound, while the lobster costs $10.50 a pound. The fish, they didn't ask the question here, but they should be asking how many pounds. I think I wrote it last time. Let me copy both of those things in and show you what I had here. It was how many pounds of fish and lobster are sold. This book, again, having a bit of a typo. You know, I poo-poo on this book a lot, and for good reason. There are a lot of, for something that is actually sold to schools, and schools use them, a lot of them, in fact, and this is an updated version, you know, they really should look at these things and go back and, you know, correct it. But how many pounds of fish and lobster are sold is the question that they did not ask, but we got to solve for here. So I'm going to let x equal the number of pounds, or the pounds of fish sold, and y equal the pounds of lobster sold. Not number of fish, number of lobster, but they are going by pounds here. Okay, so here we go. Let's make equations, kind of like last time here. 28.5 pounds total, x plus y equals 28.5. And then we go with the money, $5.25 per pound of fish times the number of pounds of fish, plus $10.50 per pound of lobster times the number of pounds of lobster. They're expensive. They're twice as much as the fish, equals $2.15.25. Now, as I see that actual thing taking form here, and I saw that $10.50 is twice as much as $5.25, I'm almost under the assumption here that this number could also probably divide by $5.25. This isn't something that I would have ordinarily picked up on and recognized, but given the kinds of equations they're giving us, it's likely. I will probably do that in the end. What I want to present to you first is If you don't want to deal with decimals, you can get rid of them with a decimal shift. And by that, I mean you can take this 5.25, and shift this 2 decimal places over to turn it into 525. And the 1050, shift 2 decimal places over to make 1050. And then shift this over to make 21,525. Now those numbers are big, and of course, as you know, I'd probably want to reduce those afterward. Some people wouldn't mind just working with the money figures and doing that, and some people just don't want decimals at all, so they'll deal with the larger numbers. And like me, I'd find the in-between. I'd love to try and divide something and reduce it as much as possible. But, you know, this step, just so you know, guys, what this also was doing, this was the same thing as multiplying everything by 100. Multiply by 100, you get a decimal shift there. Now, that's one approach. I'm going to avoid it only for the sake of, well, you know what? Here, let's stick with this. What I want to know is, can I divide this by 525? That's what I want to know. So I'm going to check that in the calculator right now. I do not know. I assume it'll probably let me, because they're probably going to make these small enough so that can happen. So 21525 divided by 525. Yeah, it's 41. Sorry, right there. It's 41. So, okay. All these numbers divide by 525, or the original one, they all divided by $5.25. Now, I am going to divide by that number, but because one of them's dividing by itself here, that 525 over 525, you know, I'm going to end up just getting X. So this is going to be X, this is going to be X. So what I'm going to do instead, sort of, is I'm going to, what the heck? I have no idea what's happening there. What I'm going to end up doing instead here is I'm going to divide by negative 525. That way, I actually won't have to manipulate my top equation at all. X plus y, I mean, well, maybe you want to, because there's a decimal. You know what? Let's live with a decimal for a moment, actually, here. Because this one's being reduced to kind of what we want. All right, so anyway, I'm going to divide by negative 525, because if the whole goal is elimination, and we'll rewrite the top equation one more time, x plus y equals 28.5. This equation right here will now allow me to eliminate x's automatically. Just divide by the negative now, and then you don't have to deal with it later. So right here, I'm going to be writing negative x minus y equals negative, I think it was 41, negative 41 there. I don't know why I wrote it on top. Sorry, minus 2y equals negative 41. So here I'll have these x's eliminate. This actually does leave me with a negative. Negative y equals negative 12.5, I think. So positive y equals positive 12.5. Now this one being a decimal, I guess, is okay. This isn't money, by the way. This is number of pounds. 12.5 pounds of lobster apparently were sold. And to find out x now, that's 12.5. To find out x now, we get x plus 12.5 equals 28.5. So that'll be, and look, it should make sense that we get a decimal, because this had a decimal with it as well. So I think we should be accepting that at least one of them does, and it looks like only one of them does. X is going to equal 16 in the process there. So what does X represent? Pounds of fish sold. So 16 pounds of fish were sold. 16 pounds of fish and 12.5 pounds of lobster were sold. All right. There's the result. All right, 4 more problems here. Number 13. Nicole has 15 nickels and dimes. So collectively, all the coins, all 15 coins for nickels and dimes. If the value of her coins is $1.20, how many of each coin does she have? So how many nickels does she have? How many dimes does she have? Once again, this is one of those previous problems here. Let me find it. Kind of just worth copying and pasting. N is number of nickels. D is number of dimes. Again, they don't tell us the value of nickels and dimes. You kind of just have to know. Nickels are 5 cents each. Dimes are 10 cents each. Now, last time, guys, you're going to probably want to find that problem where I did it. Problem number must have been 5 or so. Problem number 5. And look back at what I talked about with this here. I'm going to do the cents version. If you don't know what that means, go back to problem number 5. Please, just for time's sake. And we'll do that. Okay. So 15 nickels and dimes means N plus D, number of nickels plus number of dimes equals 15. And then the other equation here, again, $1.20 is 120 cents. So I'm going to be using the cents version. So 5 cents per nickel times the number of nickels plus 10 cents per dime times the number of dimes equals 120 cents total. I get rid of the decimal with that as well. That kind of helps. And I can take this bottom equation. You might think, let's multiply the top equation by -5, which is fine. I'm going to start pushing toward the smaller versions. I'm going to divide this by -5 right here and divide by -5. And smaller numbers. So negative n minus 2d equals negative, 24. Negative 24. And I'm ignoring this equation outright when I'm doing this. So when n minus n is boom, d minus 2d is negative d, and this is negative 9. Therefore, d equals 9. She has 9 dimes. How many nickels does she have? Well, n plus 9 equals 15, and n equals 6. So Nicole has 6 nickels and 9 dimes. Nicole has 6 nickels and 9 dimes. There it is. Okay. 3 more. Number 14, the sum of 4 times one number and 3 times the second number is 64. If the sum of the two numbers is 19, find the two numbers. Okay? It's going to be one of these. Let x equal first number, y equal second number. Again, it's kind of, I like that they did them this way, I guess, because you practice one time and then you solve the next time, but I don't know. It's just funny that they're doing that. All right, x equals first number here. 4 times that first number and 3 times the second number. We take the sum of that and we get 64. And the sum of the two numbers themselves is 19. This is probably one of the first problems, if not the first one, where I can't really divide all these by something. So instead, I'm just going to multiply the bottom by something. And these numbers are small, so that's okay. So I'm going to multiply the bottom here by -3 to eliminate the y's first here. And I'll get negative 3x minus 3y equals, I want to finish in an hour here, equals negative 57. I impress myself with how long I spend doing solution guide videos. I know I'm teaching. I know it's helpful to people, but man, if I could save time. All right, so we get x equals, in the end there, we get x equals 7. So the first number is 7. The second number, if they add to make, 7, they add together to make 19, 7 plus y equals 19, y equals 12. So you still got to answer it, though. Find the two numbers. I guess you could say the numbers are 7 and 12, but just, because the way we defined it, the first number is 7 and the second number is 12. The only reason there is so that way you don't kind of screw up that first part. If I do 4 times the second number, if I do 4 times 12 and 3 times 7 and add it, I'm not going to get 64 again. So, you have to make sure that you're doing it in the order that they kind of provide it, and then you can get that answer. So that's why it's good to do that. There are some times where you might define one as the larger number and smaller number. You wouldn't have known which was larger or smaller here. Sometimes they tell you. If we ever do a problem with a difference, where they say the difference is something, you'll know, like, if the difference is 3, then the larger number should be the first number. If you do x minus y equals 3, x should be the larger number because you have a positive difference. Positive difference, big minus small. That food I ate. Okay, number 15. Megan goes to the grocery store to buy hot dogs and hamburgers for a cookout. She buys a total of 6 packs that comes to a total of $30.46. These are going to be weird decimals. I'm going to admit, I don't know where I'm going to go to with this when it comes to decimal work. These hiccups might happen for a while here. If a pack of hot dogs costs $2.65 and a pack of hamburgers costs $6.29, determine how many packs of each she bought. At least these are cheaper than the last store that we saw a number. Okay, I'm going to get some water. I'll be right back. Stupid hiccup. Okay, I'm back. Can't guarantee that I'm better, but I'm back. All right. So let me copy and paste what I did last time here again. Number of hot dog packs, number of hamburger packs. So these are by packs here for this one. And like I said, I think they were more expensive last time. Okay, So 6 total packs. So x plus y equals 6. And this is the equation that scares me as far as if you're like me and you end up spending too long, sorry, not if like I spend too long, but if you're like me who likes to try and make these numbers smaller or non-decimals or whatever, and you take too long to make it happen, maybe it's not worth its while to do that, but equals 30, 46. But I might want to play with this for a second. Well, I don't know. I don't know if these ones do divide by anything very healthily. They don't divide by 5 or anything like that. This number, I know, doesn't divide by 3. I will play the decimal shift, though. How about that? I'll do this one with you. Let's shift the decimal, multiply everything by 100. Let's turn them into their cents equivalent, if you will. $2.65 is, or $2.65 is 265 cents, like that. Plus 629y equals 3046. I'm sure these can divide by something. I don't know what that something is. I don't know a common number for any of these that ends in an odd value that works out. So I'm just going to leave it. So with the top one, x and y, I'm going to multiply it by negative 265. And again, there's nothing really different between what I'm doing here and what I would have been doing with decimals other than multiplying by negative 2.65. Some people just don't like decimals. I'm one of them. That doesn't mean I won't use decimals. It just, just showing you that you don't have to, because a lot of people don't like them. And I'm trying to do this one in my head. 265 times 6. That's 12, 15, 1590. Negative 1590. Let's hope that's correct. Because otherwise I made a mistake. All right, 629 minus, let's just do this the conventional way. The 6, and what is that? 364y. All right, here's where I might have to use a calculator down the line, or after I subtract here. So 6. I never subtract this way anymore, where I'm doing that, like the 9, that stuff in my head. I never do. If I were to guess, I would say the answer is 4. Otherwise, it's not going to be a correct number of hamburger packs, or I did math wrong. So if I'm going to guess, I'm going to say the answer is 4. So that's 1456 divided by 364. Yeah, that's 4 right there. Okay, so that number's 4. At least I did the other math things right, as far as I'm aware. So y equals 4. That's 4 hamburger packs purchased. It must mean there were then 2 hot dog packs purchased. X plus 4 equals 6, so x equals 2. So Megan purchased 2 hot dog packs and 4 hamburger packs. Megan purchased, look, she misspelled her own name. 2 hot dog packs and 4 hamburger packs. Okay. All right, one more problem. Less than 2 minutes if I want to get it within an hour here. All right. Number 16, the sum of two numbers is 33, and the sum of 7 times the first number and 5 times the second number is 197. Oh, I don't think I'll finish in that time. I want to, because there's some math to be had here. Maybe some numbers to reduce. Copy, paste. First number, second number. So let's try and see if I can get it done in that time. X plus y equals 33, and then 7x plus 5y equals 197. Okay, these numbers can't lessen here. I can't divide by anything to make them smaller. So I'm going to multiply the top by negative 5 here. And I get negative 5x. Oh, I can finish. Minus 5y equals negative 165. Okay, so that becomes 2x equals 32. So x equals 16. I'm only trusting I'm doing that math right. So 16 plus y equals 33, and y equals 17. All right, let's say the first number is 16 and the second number is 17. Again, these problems without context or anything aren't that enticing to me when it comes to solving, but we solved it. It's good practice. We got it. All right, I finished. Okay, I still had some time to spare. All right, that ought to do it for me here, guys. If you haven't, check the description section down below if you want to see the timestamp of any old particular problem there. And of course, in the comment section, you may ask me questions as well. This was solving using elimination with setting up word problems, defining variables, writing out the answers in context when provided. Thank you, guys. Have a good one.